I'm still, you know, at precisely, you know, precisely the start time, I'm still figuring things out a little bit. So, oh, thank you, Mike. Mike English has graciously volunteered to help with the notes.
All right, we are at time.
All right.
So
I will.
I'm not seeing any slides
again.
from you.
Yeah. I'm getting there.
As long as it was in the state you expected it to be in.
Yeah, it's you know, it being being midnight local time. Do things look okay? I mean, we've got the title bar up here. Apologies, but I'm not sure I can get rid of all of that in the mode that I'm working in. I was planning on using a separate machine to project the slides, but it seems like MeetEcho only allows me to be logged in once. So we're going to do it this way.
Cool.
So, nota bene.
Well. I'm sure everyone knows that they are at the IETF, and this is an IETF meeting, and these are the policies of participating in this meeting. We'll give everyone a minute to read the details of the note well, and then take them as understood.
I mean, you all know the gist here, right? Things are things that happen in an IETF meeting are IETF contributions. So, and I guess we'll move on.
Right. So we have done the note well. Before we get to bashing the agenda, do we have and/or need a Jabber scribe? I'm so Jabber challenged these days. I don't even know where we're at with that. Do we have a volunteer to be a Jabber scribe?
So does the chat in MeetEcho still connect to the Jabber room? Is that still a thing? Fabulous. All right. So, Chris Lemons has graciously volunteered to be our Jabber scribe. So just remember to prefix your comments with Mike if you would like him to repeat the comment in audio.
Yep. Awesome. Okay, and we have a minutes taker lead in the form of Mike English. Thanks again. So this is the agenda as it was published on the website and as it was shared on the mailing list. Any final bashes to the agenda? Not seeing any activity. I think we will take that as approved for this meeting and move right along. Okay, so first thing in the category of experiences with, the category of experiences, so many experiences with video, we actually have MeetEcho here to talk about their experiences from IETF 108 and since 108. So I think you can pull up Lorenzo's slides, and Lorenzo, if you would take the floor.
Right.
I can also share the slides myself if you prefer, so it's easier for me to share the slides, unless you prefer to share them yourselves.
Why don't we give you the floor if that works? Let me. I will stop sharing.
Okay.
And we'll see if that works.
Yeah, you should see it now. So I have a separate screen for the slides, so I should be able to also monitor the Jabber room at the same time in case there are any questions or feedback.
Outstanding.
Okay. Can I start or? Okay. Yeah. Thanks for the. Okay. Thanks for the introduction. So I'll give a quick overview of how basically we changed the way that we stream IETF meetings from how we did it before. So when it was mostly an in-person meeting, and the remote participation was, of course, less prevalent than it is now. And so if we think about how we did things before, so it was basically harder from a setup perspective, but easier in terms of remote participation. And in terms of setup, it meant hooking up to the mixer board in order to allow remote participants to speak to the room, and in order to allow remote participants to listen to what happened in the room. And we had a dedicated laptop that would basically act as an intermediate participant for that. And audio was mixed, and still is, as I'll show later. For video, we would have a camera in the room, a controllable camera that we could use to monitor what was happening at any time, focus on the mic line and these kind of things, and the splitter that would capture the feed from the projector, and both would be captured by a Raspberry Pi in the room and streamed to our WebRTC server via plain RTP. So it was a quite easy thing to do, because basically a plain RTP stream would become a WebRTC broadcast as part of this. And at the same time, of course, when we had remote participation, this happened through an SFU approach, and I'll spend a few more words about this in a few seconds. But in principle, it meant that we could have a separate laptop in the room hooked to a second screen, so that anytime that we had a second speaker, a remote speaker presenting, we could basically subscribe to them as all remote attendees were doing, and show them in this additional monitor. Of course, this has gone away since the moment we started to meet just virtually. And so this meant that we had to considerably change the way that the architecture was working. First of all, we needed to work at scale, because we didn't have just, let's say, 100 remote participants and 1,000 local attendees that impacted the infrastructure much less, but everybody was remote instead, which is something that I tried to capture in a presentation that I did a few months ago at a conference in the UK, where I explained how we changed the way that it worked for live events in general. You can find the slides there if you're interested in some more details. But everything at the foundation is based on our own open source WebRTC server that is called Janus. And it's completely open source. You can find some links there if you want to play with it. And we conceived it as general purpose because it's, let's say, very modular in terms of how things are conceived in terms of functionality they provide. And I'll show that we actually use 3 different plugins in Janus for the IETF meeting itself. And since we wanted things to happen at scale, we also started from some considerations that were part of my PhD thesis a few years ago, which was basically how to achieve large-scale broadcasting via WebRTC in the first place in an architecture that we called Soleil. And the approach was basically taking advantage of some sort of a tree-based architecture where you can have a participant injecting something via WebRTC. Everything in the middle doesn't need to be necessarily WebRTC. It can be plain RTP, for instance, as it is in our case, as long as at the end, when you trickle down the streams, at the end you feed servers that are able to turn this feed into a broadcast, WebRTC broadcast again, which is, in a nutshell, what I'll try to explain today. And so, first of all, in terms of audio, there are, of course, challenges for both audio and video, because the IETF is not just a plain broadcast. It is very much conversational. It is very much interactive. So just following the architecture that I showed before wasn't enough, because otherwise it wouldn't be able to make questions, to have interactions, and so on and so forth. And so we basically took a couple of different approaches for audio and video. And for audio in particular, we chose a mixed approach instead, following pretty much the same thing that we were doing before we changed the event, because at the time it was mixed as well. But in this case, we chose a slightly different approach, and we learned a bit from how podcasts worked during the pandemic, because they became even more popular during these past months. And of course, everybody was remote in that case. The podcaster was remote, the guests were remote, and the audience was remote as well. And of course, WebRTC is definitely a good fit for the conversation part, because it's easy to have a chat using your browser. It's what we are doing right now. But in principle, broadcasting can be done via WebRTC as well. And there are a few advantages of having everything mixed. So first of all, it's easier to broadcast and distribute. It's easier if you have some participants that are struggling with the network, and so can always rely on a single, at least, at the very least, on a single audio mixed stream that would consume very little bandwidth. And besides, if you are broadcasting, you probably still need to have some transcoding anyway, which is why it makes easier to have it mixed. And it also makes it easier to inject some pre-recorded content, and I'll get back to this later. And so what we wanted to do was try to figure out a way to basically put these two things together. On one side, broadcasting to a lot of people, and at the same time allowing some of those people to interact with each other. And the way that we do this with Janus is using the Audio Bridge plugin, which is basically an audio MCU. So if you imagine these three participants are all active and talking to each other, as Mikhail and Leslie were doing up until a few minutes ago, there's actually something in the Audio Bridge plugin that is always relaying a mix of this conversation to a separate component. And we call this feature RTP forwarding, that we use for a plethora of different use cases. In this specific use case, we use it to facilitate the broadcasting of the stream. So imagine that you have the audio bridge that is only mixing the active participants at any time. And so basically it weighs very little on the CPU because you only have a limited number of participants being mixed. This mix is always sent in real time to another component that can just worry about the broadcasting part. And so all the passive attendees are actually subscribed to this additional component that is the streaming plugin, which of course is not doing any mixing, it's not doing any transcoding, it's just doing broadcasting. So it's very effective and lightweight on the CPU. And we chose this approach because, of course, if you have a room with 200 participants, it makes little sense to have them all join the audio bridge, because it would mean each of them would have a separate encoder, which would basically kill the CPU at the very end. This is a much more optimized way of doing things. But again, as I said, we want people to be able to actually participate in the conversation, which means that anytime that one of the attendees, the passive attendees, must be an active participant instead, for instance, to make a question or becoming the presenter themselves, what happens is that we escalate them to an active role. So anytime you press the mic button, basically what happens is we mute the local stream, the passive stream that you were receiving, and we have you join the audio bridge directly instead, which means that you start receiving audio from the audio bridge, so from the mixer itself, and you are able to inject audio yourself. And of course, whatever you say is then injected back in the streaming plugin and then forwarded to all the attendees, which is why we basically mute your own passive stream instead, otherwise you would hear yourself back. So this is basically in a nutshell how it works for audio. And of course, this RTP forwarding mechanism allows us to actually broadcast these to more than one instance. So the moment that we need more servers to serve a wider audience, all we need to do is to make sure that this mix is available on other instances as well, so that multiple streaming instances can serve a subset of the attendees instead. And this kind of approach is also quite useful for another use case, which is not needed for the IETF, but was actually needed for a couple of other events that we've served in these past few months, which is making it very easy to have channels with different languages. I mean, just last week we had the INOG meeting by RIPE, and they actually needed two separate channels for two different languages. And so using two different mixes for the two languages and an interpreter that can listen on one and speak on the other makes it very easy to do something like this and broadcast this seamlessly. And so that you can have the audience very easily switch from one language to another anytime they need to, which would be, of course, much more complex if all the streams, the audio streams, were separated from each other. For video, the approach is a bit different because we, of course, don't do any video mixing here. As you can see from the UI, we are using an SFU approach. So each video stream is separated from the other. And for this, we basically took some lessons from the so-called webinar approach, where you typically have some sort of a one-to-many scenario where you have a single presenter injecting media and then distributing this to a lot of passive viewers. And of course, I mean, again, the IETF is mostly conversational. We can have multiple active streams at the same time. And it's not only different people speaking. In this case, I'm sending two different streams myself because I'm sharing my webcam and the slides at the same time. And so, of course, you need to take this into account. But if you look at it from an architectural perspective, you can see each video stream as its separate broadcast. So each video stream is a one-to-many broadcast, if you want, that is then tied together from an application level perspective from the application itself. So it's the application that knows that my webcam and the screen from the webcam from the screen sharing need to be part of the same application. But in terms of how they flow into the architecture, they are actually separate broadcasts that can be then scaled separately as well. And of course, again, WebRTC was the best fit for that. A lot of conferencing applications use it every day. And again, as I was saying, we are not mixing video for the WebRTC use case, but we do perform some video mixing for another use case that I will get back to into a few minutes. And so for video, we are using a different plugin. So we are not using the Audio Bridge plugin that only does audio mixing, but we are using the Video Room plugin, which is an SFU instead. So it basically just relays packets, which means that if we have a participant publishing media in a video room, then other participants can subscribe to this stream if you want, which is basically how all these SFUs work. And the interesting part is, of course, that this plugin, just as the Audio Bridge plugin, does support the so-called RTP forwarding. So we are able to take the stream from this publisher and relay it as a plain RTP stream to a separate component to do whatever we want with it. So some people are doing it for using it for identity verifications, others are using it for post-processing or live recording. And in this specific case, we are using it again just to facilitate the broadcasting part, because the Video Room plugin itself is perfectly capable of serving a number of passive attendees itself. But the problem is that we can't anticipate how many attendees we will have in any room, and we want to scale as much as possible. So for instance, you have the plenary where you have hundreds of participants instead. And of course, the video room itself on a single Janus instance may not be able to sustain that load by itself. So it's much easier to instead use the video room plugin just for ingestion. Then you pass the RTP stream as it is to a streaming plugin for distribution. And then it's up to the streaming plugin, which is more optimized for broadcasting functionality, to then distribute this to a wider audience. And again, we can take advantage of using multiple streaming plugin instances for distribution instead, which again brings us back to that previous slide that I had on tree-based distribution. So the wider the tree is, the more attendees you can serve, of course, and because you can serve multiple nodes for the distribution part. And of course, since we are just working with plain RTP, it's also very easy to distribute without actually using other WebRTC components in the middle, as long as you have WebRTC functionality on the edge, which is what we do. And so from a functionality perspective, as I was saying, video can be treated as multiple one-to-many broadcasts, which is exemplified in this very ugly picture that you see over here. So in this case, we have two different participants injecting video, and they are also talking to different video room instances, which isn't happening in this setup of the IETF, but will probably happen soon. In this case, you have then both participants injecting their own stream, which is then distributed to all of those 4 distribution nodes that you see. And the same happens for the both of them, which means that from an audience perspective, it really doesn't matter that it's different participants and that they are being fed to different instances. They are both seen as 2 separate streams that they are receiving from the same server they are connected to. So it's quite an effective way of distributing streams without worrying too much about tying the 2 streams together. So it's, again, very different broadcasts that we can distribute their own way. And so bringing it back in an even uglier picture than before, this is how it looks in a nutshell. So you have active participants connected to the Audio Bridge for speaking and to the Video Room plugin for sending their own video streams. And all of those streams are then forwarded to a plethora of streaming plugins for the distribution part, which means that no matter where you are ingesting streams, the moment you hit a streaming plugin instance, you are able to receive those streams nevertheless, which means that we are then able to scale to any number of participants in theory, because it means that we just need to increase the number of streaming instances devoted to the broadcasting part. We just need to update the distribution tree behind the curtains accordingly. And I mean, all of this effort eventually led to what you saw at IETF109 in Madrid, so that the interface maybe didn't change as much from the one that you were used to when the meetings were actually in person and you were attending remotely, but there were a lot of changes actually, especially in terms of how the streams were managed. But there were actually a few changes since then. So, and I'll try to spend a few words on those as well, just in case you're interested. And first of all, I mentioned the distribution tree, and during IETF108, that was indeed the case. So we had indeed this scenario that you saw over here. So each ingestion node was actually distributing the stream proactively to all of these streaming instances that you see over there. So it needed to be aware that there was a streaming instance available. And so the moment a new one appeared, we had to basically tell all of these components to start relaying the traffic to this additional node instead, which works, but it is indeed a bit of an orchestration burden, which is why we were very happy that this time instead we could take advantage of multicast support instead, which the cloud provider that we use in 108 didn't. So we had this multicast support available for a long time, but we just couldn't take advantage of it, which we now can. And this means that these instances that you see over here are basically, you still have one audio bridge, you still have one video room, but they are just sending a single stream via RTP forwarding to a multicast group instead, which means that any streaming instance, any distribution instance that you see over here just needs to subscribe to the right multicast group in order to receive the stream they are interested in. Which means that if in this case we add yet another streaming instance over here, they just need to be aware of the multicast group that already exists to be able to receive the media automatically. So these components don't need to do any additional effort. So they don't need to add any forwarding rule themselves. And another interesting thing that we did already support in 108 and we tried to improve in the meanwhile was support for pre-recorded talks. Because in the applied networking research working group, there was actually the requirement to have some pre-recorded talks as well, rather than just live presentations, which of course could be seen as a bit of a challenge, because right now we are all talking actively, we are all capturing our own webcams, our own screens, and so on. And instead, in that case, we had several pre-recorded presentations that we wanted to play live through the same Meet-Echo interface as if they were live, but they were pre-recorded instead. And this was actually pretty straightforward to do in terms of how the architecture worked in the first place, because the streaming plugin that I was mentioning that basically allows you to do the broadcasting part actually works by taking plain RTP inputs as a source, which is why it works so nicely with the Audio Bridge and Video Room plugins as a source themselves. So all we needed to do was basically take those pre-recorded files and stream them via RTP using a tool like FFmpeg or GStreamer or any other open source tool that is available, and then stream those to the streaming plugin instances that were associated to the room, and that basically would become a new broadcast that people in the room could subscribe to. There was a bit of an issue here though, and specifically the fact that for pre-recorded presentations, in this case, audio was going through the streaming plugin instead, which is why people rightly complained about the fact that the volume controller in the Meet-Echo interface was not working for them in that case. And that was indeed expected, because the volume slider that you see in the room only acts on the audio that you are receiving from the mixer, so from the audio bridge. And in this case, we were bypassing that component, which made for a slightly awkward experience. And so we actually changed that in 109. So right now we are actually injecting pre-recorded presentations as a regular WebRTC participant, and which means that they go directly both in the audio bridge and the video room, and they are distributed exactly as a regular participant would, which makes it much more transparent to the infrastructure in place. We plan to get back to plain RTP because we can inject plain RTP video in the streaming plugin. We did that just the last meeting, and we can actually also play a pre-recorded audio file in the audio bridge itself, but it is something that we plan to do for the next meeting, also because we had some weird network behavior that we can discuss later if we have questions, so that basically prevented this from happening. So this made for an easier process instead. And finally, to conclude, I mean, I was mentioning that we don't do any video mixing for the plain WebRTC participation that you see over here, but we do have to do that sometimes, especially when we need to broadcast some of the working groups to YouTube Live. So, for instance, the technology deep dive or the plenary, some sessions always need to be broadcasted to YouTube as well, which means that in that case, some mixing needs to take place, because of course, any CDN provider like YouTube needs to have a single audio and single video stream to be able to broadcast them to their audience. And the way this works is we take advantage of the same RTP forwarding functionality that I was mentioning before. So in this case, we have an MCU component that, just as the streaming plugin instances, is subscribing to the same multicast groups that I described before. It's receiving those streams, so it's receiving the streams from the active participants, the audio and video streams. mixes them all together, and then generates in real time an audio-video mix that it can send via RTMP, in this case to the CDN, which was YouTube, and which can then be distributed via the CDN through its own means. And you can see an interesting example in the technology deep dive session from last time, because in that case, we also had a very active participation from the participants there. So at a specific point in time, you had 4 different participants interacting with each other, which again is treated as an SFU approach by WebRTC participants, but was actually mixed in a single stream when sent via YouTube instead. So at any time, we could dynamically change layouts. So for instance, focus on the slides and on the speaker when needed, or possibly change the layout so that it would accommodate multiple people discussing the current slides, or maybe focusing more on the presentations and less on the slides, or focus exclusively on the conversation instead. At any rate, this is something that was working for 108, and basically it still works. It will still work pretty much the same way for 109 as well. And this basically covers my presentation. I hope I didn't go too fast, especially because I had a lot of slides and I wanted to make sure that I had enough time to present them all. So I'm happy to answer any question if you want. And by the way, I already see Colin asking something. He's asked how many participants are reasonable combined in this way. In principle, there is, let's say, I don't know the maximum layout we accommodate programmatically what it is, but we had some MCU sessions that accommodated even 20 or 30 people in the same MCU stream. I don't think it ever happened for IETF meetings, but it happened in some other contexts.
All right. Any questions? Anybody want to get into the queue?
I say Jake asking what happens if we all turn on our mix. I mean, in theory, it's just about 40 people in here, so it should just work. But of course, the more people you have active in the same audio bridge instance is of course going to weigh a bit harder on the CPU itself, which is why we tried to optimize things as much as possible and broadcast as much as possible, rather than everybody turning on their mix, which of course also makes little sense because 40 people talking at the same time is going to be chaos anyway. So about Azure, I'm not exactly sure about that because I'm not responsible for the DevOps side of things. If you can send us an email, and Alessandro will get back to you with more information. I think it's a single data center, but I may be wrong on that.
So a question from me. I'm curious how much of this gets architected and fixed for a given event, or how much of it is dynamically configurable on the fly.
Yeah, we actually had a few meetings that shared very much the same architecture in the past. So, for instance, we had a meeting for the Afrinic yearly session. We had a couple of RIPE meetings this past couple of weeks. And you could say that 95% of the code was exactly the same, and we had to just tailor some specific functionalities to some use cases. So for instance, for this ENOG meeting, we had to support these bilingual streams, which was just a minor change because the architecture already allowed for it. And most of the times it's just visual changes. So it's a matter of adapting the user interface for some specific things or some functionality that are very much specific to some use cases. Because for instance, the virtual ham functionality that we had in 108 was very much an IETF requirement and was never needed for any other use case. The functionality that we have here for raising your hand may be more generic and so may be reusable in other contexts, but is again something that we started working specifically for the IETF instead. So as far as the audio-video distribution is concerned, it's very much the same in all contexts, and so that part is basically reusable in several different contexts.
Cool. And I see there's a question from Jake.
Is there a write-up? Jake is asking if there is a write-up on the multicast setup in the cloud, and this was in Azure. Yeah, basically the setup that we had in 108 was, I think, using Google Cloud Servers, and we do know that setup didn't have multicast support, at least at the time, while instead Azure does support it. And again, Alessandro can provide more insights about specifically why Azure supports it now and how we could take advantage of it. But this was definitely the first time that we could.
Great.
All right.
Any other questions?
Yeah, as Eric is pointing out, yeah, the streams work over IP version 6, and this is thanks to Janus in the first place. So as I anticipated, all that you are seeing is actually based on a completely open source component. So all the stream that is responsible for the audio and video streaming is completely open source, and you're completely free to use it on your own terms. And that component does support IPv6 out of the box. So as long as the infrastructure supports it, and we've been lucky that in both meetings we could have that opportunity, then this comes out for free, basically. So it just works.
Cool. All right. Well, thank you very much for sharing that. That was very interesting.
No, thank you for having me here. It was a nice opportunity. Thank you.
Good. All right. Not seeing any other questions. Moving along in our agenda, which I know I have here somewhere, or maybe Kyle's about to pull it up. Woohoo!
There we go.
Yeah. Great.
So next one is media operations use case for augmented reality. Let me pull that up.
I saw Renan here earlier.
I'm getting there. I'm still working through the working the turkey through. So there we go.
All right. Okay, so we have your slides up. Renan, if you want to go ahead. Jake can drive. Kyle can drive.
Can you hear me?
Yes.
Yes.
Okay, perfect. Hi, everyone. My name is Renan Krishna, and I will be presenting a media operation use case for an augmented reality application on edge computing infrastructure, which is a joint work with Akbar Rahman. Next slide, please. So let's start with a brief introduction of our interest in the work being done by the MOPS working group. I work for InterDigital Europe Limited, and we are, through an acquisition of Technicolor, active in various AR/VR related technology development. For example, at MWC 2019, we demonstrated our technology for 360-degree video experience with adaptive streaming, volumetric technology for video, and virtual reality video streaming. We are also participating in other STOs listed in the slide. The internet draft titled Operational Considerations for Media Streaming Media by Jake Holland and others provides an overview of operational networking issues that pertain to QoE in delivery of video and other high bitrate media over the internet. Our draft intends to be complementary to that draft by covering the increasingly large number of applications with augmented reality characteristics and the requirements on ABR algorithms. We propose a use case to highlight the unanticipated requirements on ABR algorithms in AR applications. Next slide, please. So the use case is as follows. Consider a group of tourists who are being conducted in a tour around the historical site of the Tower of London. As they move around the site and within the historical buildings, they can watch and listen to historical scenes in 3D that are generated by the AR application and then overlaid by the AR headsets onto their real-world view. The headset then continuously updates their view as they move around. Now let's take a look at what the AR application is doing and how edge computing infrastructure can help. Next slide, please. The AR application processes the scene that the walking tourist is watching in real time and identifies objects that will be targeted for overlay of high-resolution videos. It then generates high-resolution 3D images of historical scenes related to the perspective of the tourist in real time. These generated video images are then overlaid on the view of the real world as seen by the tourists. In order to achieve hard timing constraints of a few milliseconds, computationally intensive tasks can be offloaded to edge devices. The edge device providing the computation and storage is itself limited in such resources compared to the cloud and can be overwhelmed by a sudden surge in demand. Additionally, the throughput to the user over the wireless link will suffer. The user will perceive a fall in QoE of the video being rendered on her AR device. In such a scenario, the client AR applications will need to use adaptive bitrate algorithms that choose bitrate policies tailored in a fine-grained manner to the resource demands and play back the videos with appropriate QoE metrics as the user moves around with the
Renan? Yeah, I can't hear his audio. Try reconnecting your audio. The little recycle icon in the lower right.
Can you hear me now?
Yes, you're a little quiet.
Okay, I'll try and speak up.
Yeah, no, it sounds fine now. Okay.
Perfect. So should I go
Next
through
slide?
the
We got right to the end of the slide and then your audio cut out. I thought you were doing some sort of like pregnant pause kind of thing.
Sorry about that. Okay,
no,
so
no
let
worries.
So let me go through the last part of the slide. So in a scenario as shown in the previous slides, the client AR application will need to use adaptive bitrate algorithms that choose bitrate policies tailored in a fine-grained manner to the resource demands and play back the videos with appropriate QoE metrics as the user moves around with a group of tourists. So let's take a look at the requirements imposed on ABR algorithms by the use case. Next slide, please. So the first requirement is offloading computationally intensive tasks to the edge. Offloading to the remote cloud is not feasible for applications with AR characteristics, as the end-to-end delays must be within the order of a few milliseconds. In order to achieve such hard timing constraints, computationally intensive tasks can be offloaded to edge devices. So this is essentially making best effort service of the internet. The second requirement is using AI ML-based mitigation techniques to select appropriate bit rates. Learning models developed in situ rather than simulations are more accurate in their adaptation decisions. Next is dynamically changing ABR parameters. The ABR algorithm must be able to dynamically change parameters given the heavy tail nature of network throughput. In such distributions, law of large numbers works too slowly. The mean of sample does not equal the mean distribution, and as a result, standard deviation and variance are unsuitable as metrics for such operational parameters. Fourthly, handling conflicting QoE requirements. QoE goals often require high bit rates and low frequency of buffer refills. However, in practice, this can lead to a conflict between those goals. For example, increasing the bit rate might result in the need to fill up the buffer more frequently, as the buffer capacity might be limited on the AR device. The AR algorithm must be able to handle the situation. Finally, handling the side effects of deciding a specific bit rate. For example, selecting a bit rate of a particular value might result in the ABR algorithm not changing to a different rate so as to ensure a non-fluctuating bit rate and the resultant smoothness of video quality. The ABR algorithm must be able to handle this situation. Next slide, please. So as a conclusion, I would like to point out these two references. The first reference is an outcome of a project that streamed over 38 years of data with over 63,000 distinct users, and compare the performance of several ABR algorithms listed in the slide. The second reference documents the problems with current ABR algorithms. Thank you for your time, and questions, suggestions, feedback are welcome.
All right. Any? Oh, we've got two people in the queue. Well, we've got one in the queue. Colin, go ahead. I'm not sure that I have any tool to recognize you other than just announcing. You have to turn your audio on. You're muted.
Still muted.
Yeah, Colin, you're still muted. I think with the new Meet Echo interface, you need to unmute yourself. It's the rightmost icon right underneath your name. Still can't hear you. Try reconnecting your audio, the recycle icon in the lower right of the window. Yep.
Okay, let's see if this is working now.
Yep, we can hear you now.
We can hear you.
Okay. So I had a question about the requirements. I've heard this few millisecond requirements. I see it quoted regularly, but I do work a lot with these devices, and I don't understand where that comes from. Could you walk me through that a little bit more? I mean, I understand why when you rotate your head, you need to update your display at probably over 150 hertz, but I don't understand why that means the video flow needs to be that rapid. Can you walk me through that requirement a bit?
Yeah, no, that's a very good question. And I actually agree with your observation that the devices themselves are quite fast these days. The problem is actually the fact that you have to do a lot of processing in these devices to overlay the scene that the viewer is viewing with something like we are envisaging a historical figure, for example. And to synchronize that with the view of the observer is quite challenging. And at the same time,
you're saying
have
doing the SLAM computation, when you say, I don't understand. I want to dig a little bit more detail into that. But what is computationally intensive these devices are doing? Is mapping their location in the real world or rendering the video?
Yes, so both. So they're
Okay.
mapping the location of the objects and identifying the objects in the real world, and at the same time, they are trying to overlay an object onto that image in the real world in a manner that looks natural to the user.
Sure. So even devices, every single device on market does that quite well, not necessarily the recognizing all the objects, but the recognizing the objects certainly doesn't need to be done in in a few milliseconds. Only the computation of the SLAM algorithm to figure out the orientation of the headset, which every headset on the market today already does.
Okay. Yeah, so no, absolutely. I think the problem that we envisage is that when you have a lot of users all simultaneously looking at a particular scene, and you have to do that sort of processing in real time, there is a problem there because there is sometimes a requirement for a huge computational resource near the AR/VR headset to be able to process that kind of thing. Whereas what we are, and besides,
I mean, that's why I keep hearing about this. I'm not sure what it's computing. That's the thing. I'm never sure what that edge resource is actually computing.
Yeah. So the first thing that they are computing is essentially the perspective of the user, and what are the objects that the user are seeing. So there is a computation that needs to be done to recognize the objects. Once you have recognized the objects, you need to be able to render a particular object that you need the viewer to see overlaid on the scene. So that's a lot of computation. And often as a result of just these 2 bits of computation, the headset tends to start getting hot. It might be draining on the energy resources, etc., etc.
Okay. Thanks for helping me understand that.
All right, thanks. And Jake.
Hi, Ronan. Thanks for this. It was an interesting document. I'm curious, are the sort of requirements described, these are based on a particular set of systems? Like, is it defined whether you're using point cloud for the overlay of the AR objects, or whether you're trying to render a video from a point of view that's part of this? Or are these like 2 possible implementations of the same kind of user visible feature, or and are the requirements different between them, or what exactly?
Yeah, thanks, Jake, for that question. At the moment, we are looking at the general set of problems. So both of those implementations are included in our set of requirements. But as we go deeper down, let's say picking one technique over the other, we will have more specific requirements. But this document was essentially looking at the big picture. Really, it didn't really go into very deep specifics of what particular algorithm or what particular technique we are using. But definitely point cloud, viewport, adaptation, all those things are at least at the moment part of the requirement. But as you go down that particular branch of technique, you will need some specific requirements for those as well. Yeah.
Okay, thanks. And then I guess I'm not clear on whether you're aiming for adoption on this doc, or and if so, like, is it you're looking for that now, or like maybe next time, or I don't know, like what's the ask here?
Yeah.
Or you're just
yeah. So we envisage your draft as being a route to a taxonomical tree of media operations. And one of the branches out of that route is ABR algorithms, whose sub-branches are use case. So definitely we'd like to have feedback from the working group. And I think this is a very good opportunity to this question answer session is a very good opportunity to look at various directions this draft could go to. And definitely we'd look for an adaptation at some point.
All right, great, thank you.
And Spencer. If you're speaking, we cannot hear you. Now we can hear you. Yes.
Okay. Interesting. Sorry. Yeah. So from an operations recommendations perspective, are you seeing the recommendations that you're going to be headed towards to be more about the communications aspects of this, or more about the like provisioning and of edge computing and computation?
fantastic question, Spencer. So this particular document is looking at specifically the adaptation aspects of ABR algorithms. And of course, one of the inputs to such algorithms is things like network throughput and buffer latency. So this document is very narrow in that respect, in the sense that it merely looks at those inputs to adaptation decisions. But if the working group decides that we also need to look into some communication aspects, I know that there is this issue of not stepping on the toes of other groups, then definitely we could have, at the very least, certain pointers to what kind of communication protocols need to be adapted for this, RTP over UDP, maybe SRT, I don't know.
Great, thank you. And I am admiring very much the cats that Leslie and Kyle have, and I apologize because my cats are asleep in bed because they're lazy. Have a great IETF.
This one would prefer to be asleep right now, I'm pretty sure. So.
And mine just discovered me and would have started howling. So this is the fastest way to make sure he doesn't howl. Anyway.
So next in the queue is Shui Zhao. I'm sorry if I butchered your name.
That's correct. This is Shui. Can you hear me?
Yes.
Great.
Yes.
Thanks.
Please go ahead.
Thanks for the documentation. Sorry, it's my cleaner. I'm just looking at the ABR parameters, the algorithm. Would that be specific to AR? I'm trying to understand the algorithm's difference for AR, VR, or 360 videos. Can you be more specific on that?
Excellent question. So with applications such as AR and VR, the problem is that the various parameters that such algorithms take, most importantly network throughput and the size of the buffer, they change very rapidly in such use cases as the user is moving around, and often this is referred to as volatility of the conditions. So associations between various logical associations between various software components break up and then form again. So the problem is specific to AR and VR use case in that there is a very rapid change in these parameters, and so the input to the ABR algorithm is changing very rapidly because these parameters are changing very rapidly, and the ABR algorithm needs to adapt accordingly. So as opposed to the traditional scenarios where the parameters are changing but not as fast as in an AR/VR scenario.
That's it. Thank you.
All right. Any further questions? Anyone else? Going once, going twice? Looks like the queue is empty.
I think there is some question here about where from here, either with this document or how can we help this document work, progress, suggestions for other parts of the IETF that should take it on, or whether there's a future discussion here. So Renan, would you like to share your thoughts on what you were particularly looking for other than immediately getting some feedback?
Yeah, so we definitely look for an adaptation by the working group, if everyone agrees at some point. And towards that goal, we are looking for the kind of discussion we've just had, and adding that stuff and those things to this document. But again, this is a question back to you as well. Is this an appropriate approach? So
I think that I think that with 40 people here, we're probably not, well, we aren't quorum. So I think it sounds like you've had some good feedback, and maybe the next step is to do a turn of the draft, a new version of the draft with those updates, and then we can take it to the mailing list and see if people want to adopt this as something to move forward within the working group or have other thoughts. Does that make sense?
Yeah, absolutely.
And I will ask the same question sort of more generally to other people if people think that sounds like a good path forward here. Any objections, I guess? And I am not hearing any objections, so let's do that. Great. Oh, Spencer, you're in queue.
I was just asking if it looked like that you were going to be identifying any changes to internet protocols that are used here, or is what you're expecting to be doing mostly in the operations recommendations space?
Again, fantastic question. So from our perspective, we would like to do both. The question is that is MOPS working group the appropriate working group to do the protocol bit, or is it just that we identify the operational issues that lead to certain questions that can then be taken to other working groups? So my answer is
the latter.
We'd be happy to do both. Okay, so the latter. So I suppose we'd be happy to identify operational issues that then lead to certain requirements for communication protocols, and as our internal project, definitely we are interested in the protocol bit as well.
Cool. Thank you so much.
Thank you.
I think that it will work well for this collection of people to help work through the operational aspects, and also thereby bring clarity to the protocol questions to take to other working groups. So the protocol work doesn't get done here, but we can probably be helpful in terms of making sure that the questions get asked in a useful way in other groups, if that makes any kind of sense whatsoever.
Absolutely.
Great. All right. Looks like the queue is empty, and thank you very much.
Thank you.
Thank you. So next up is Victor with the web transport slides. Let me grab those. See, if I were smart, I would have had them all loaded up, but I'm just presuming that you want me to run the slides. If you want to share, Victor, that's fine with me.
I don't think I have them ready, so it's probably easier if you run them.
Okay. Just give me 1 second. And all right.
Hello, everyone. My name is Victor Vasiliev. I work for Google, and I want to present to the MOPS working group some information about web transport. Web transport is a new combination of a protocol and an API that is currently being jointly developed by IETF and W3C. That is, I'll explain what it is, but next slide. So, the goal of web transport is fill the gap where WebSockets exclusively provide reliable order delivery over TCP, and there is an unreliable or unordered way to deliver data called RTC data channel, but it's designed around a peer-to-peer use case, and it has a lot of rough edges. Next slide. So as a solution to that, we propose a new thing called web transport, which is essentially trying to expose semantics of quick connection to the web API. It is does not let you create direct quick connections, but it gives you similar semantics, and it is different from WebSocket in the sense that WebSocket is message-oriented and WebTransport is stream-oriented. Next slide. So the target applications is anyone who wants something like WebSockets, but they want something like WebSockets, but for UDP, or they want to have multiple streams of independent data that they send, and they want to send it without head-of-line blocking. There are a lot of various use cases we have in mind. The very original one were web developers who were working on video games on the web, and they would benefit from sending things like user input and game state updates over something that would normally be UDP-like, but on the web they were stuck with WebSocket because WebRTC is too hard to handle for smaller web developers who don't have a backing of framework. There are lots of other use cases. There are people interested in using this in live streaming, cloud gaming, remote desktop, anything that needs low latency, even things that do not need unreliable cases like web chat still benefit from those. Next slide. So WebTransport, and I said, it provides quick semantics. It provides streams and datagrams. The streams are quick streams. They are essentially just like TCP connections, except it is very cheap to create them and it's very cheap to cancel them because of the multiplexing, and they all share congestion control context. And by cancel, I mean when you reset a quick stream, it is a form of unreliability because all of the underlying data is not retransmitted even if it gets lost. Datagrams are effectively a simulation of UDP semantics on top of Quick. They are, in our opinion, a better version of what DTLS is currently used for because you can multiplex it with reliable data. Next slide. So WebTransport, we have a lot of design requirements, but what we require of our protocol are, we require it to use TLS, we require it to use congestion control, which is important because regular UDP does not have any form of congestion control. But since we're in the browser, we have to ensure that the resulting connection will not overload the network. We require server to be able to know the origin of the web page, which originated the request, in order to enforce the ORS. We require to have a mechanism to prevent cross-protocol attacks, i.e. attacks of where you're one protocol and then you get confused for another, and this allows you to break security boundaries. We require this thing called consent to send data, which is effectively the server has to continuously indicate to the browser that it still wants to talk to the client, and that's important because if you do not have that, it is very easy to use your API for a DDoS attack. And we provide, every WebTransport endpoint has a URL, and that allows it to integrate with a lot of web features like content security policy, etc. Next slide. So why would you use WebTransport for media? Well, compared to WebRTC, there are multiple advantages. One of them is that WebTransport is oriented to client-server, which is a lot of media, especially that's not video conferencing, is a client-server, like any form of live streaming is essentially. Does not need to use ICE ever. And the second is that you can build on top of existing infrastructure built for Quick. For instance, Google and a lot of others build Quick libraries because they want to do HTTP free. And that means any improvements that we make to our HTTP stack, to our Quick stack, that for sake of improving HTTP can also be used for improving any media delivery. This is in contrast to things like RTC data channels, where they use SCTP in user space, which is effectively limited to RTC data channels, so you do not get a lot of code reuse from that. The advantages of our HTTP-based approach is one of them is that protocol is inherently bidirectional. That means whenever you want to push a media chunk, you do not need to send a request and then get that media chunk. You can just push it, and that simplify things. And this also means that you can do it the same protocol in both directions. So for instance, something like Dash or HLS can be used to stream video from an HTTP server, but if you try to use it for contributing video, you have to configure your server to which you send video to pull from your from your professional video equipment or from an intermediary service, and that's suboptimal user experience. And of course, it is more extensible because once you remove the strict HTTP semantics, you can experiment to do whatever you want with it. Next slide. So what's the current status of web transport is we have a working group that's in both IETF and W3C. Kyle, I think the slides went away, at least for me. See.
Kyle's back.
Yeah, so there is a working group in both IETF and W3C, and both are actively working. And we're discussing issues and discussing which draft to adopt. There is an implementation of part of web transport called Quick Transport. It's currently available in Chrome as Origin Trial if you sign up for Origin Trial, or if you go to Chrome Flags and enable experimental web features, you could use that. And we appreciate all feedback, and there are some links on the GitHub repo for API spec, and there's a web.dev article on how to use this API. Next slide. Next slide.
Not hearing you. And I think Kyle needs to recycle his. I'm not sure if he's even seeing the chat window. I'm gonna start making hand waving motions shortly. This will be fun.
Can Fox hear me?
I can hear you.
Okay.
Oh yeah, I can hear you now. I had to unmute for some reason to get audio started. That's weird.
Okay.
Anyway, yeah, the in the middle of your last slide, basically my entire my entire Mideco session just blew up.
Okay, what is? Do I need to go back slide, or do I need to just repeat the slide?
No, I think starting from the web transport status slide again.
Okay.
Would be fine.
Okay, so web transport status. There is a working group. It's formed in both IETF and W3C. Both are actively working on things. If you file issues, you will get reply. There is a partial implementation of proposed web transport API in Chromium. If you sign up for Origin Trial, or if you enable it in Chrome Flags, you can experiment with it. We appreciate all feedback on both on implementation and on the design and on the protocol, etc. There are some links below of where you can read more. Next slide. So regarding specifically standardizing media over web transport, there is no actual current effort to standardize this. And the reason for that is the web transport is just being developed. So if I don't think while people are building things on top of them, none of the things they're building on top of it are at the stage where they're ready for this. I am aware of efforts to do both video live streaming and real-time applications. Yesterday, Fox from Twitch presented on their efforts to do live streaming over web transport at the Web Transport Working Group meeting. And I am aware of multiple attempts. I don't remember specifically, but there are definitely multiple attempts to build game streaming systems on top of this. And so it is unclear what would be the way forward to standardize something. I know that RIPT BOF, there was an interest in building standard for sending media over web transport. I do not know if that has made any progress, but that sounds like one possible avenue. But I expect at some point somebody will build something on top of this, and hopefully they will bring something here, and if they believe that's useful for them. So that's the current status of standardizing media. That said, there are definitely people who are at least trying to do this in practice. So that's it. Next slide. Do people have any questions?
All right, Luke, go ahead.
Hey, so I'm the guy at Twitch that gave the presentation yesterday. We're mostly exploring it as an HLS or contribution alternative, just as a way to reduce headline blocking. And it might be something that Twitch would be interested in trying to standardize as well. But we're still prototype stage. We haven't released it or anything yet. But yeah, I'd love to talk more about web transport as well. If anybody has any questions, I've been involved in the staff alpha and the working group pretty heavily now. Sorry, that wasn't a question.
Interventions are allowed. Cool. All right, should we go along then to the next in queue?
Mike? Can't hear you if you're speaking.
All right. Is my audio on now?
Yep, can hear you now.
Great. So I just wanted to ask if there were open source implementations of media delivery. I know, Luke just mentioned that Twitch has been experimenting. I've heard of a few others at the working group, but does anybody have sample code out there?
For media specifically, I do not believe I've seen any sample code. That said, I'm thinking of everyone who I've experimented, who I've talked to, and I do not believe any specific projects I've talked to are currently open source. Some of them might get eventually released as open source, but I do not believe there is a specific example. But even if you read the Web Transport Explainer, it has some examples of just how you could take a chunk of video and connect it to media source extensions. So that is like to build something really simple is not particularly hard. But I do not believe there's any specific examples of sending media over web transports that currently work.
Any more questions? Anyone else? Going once, going twice. All right. Thank you, Victor.
Great. That was really helpful. Thanks.
I assume there are no more questions or remarks, so.
Yep, I think we're good. Thank you.
Yep, thank you. All right. Now we are back to the agenda, if I can find it.
Yeah, we saved the most compute intensive part for the last.
Great. It's now 1:15 a.m. where I am.
Ditto.
All right, so go to the milestones slide.
So I proposed this agenda item when during the interim, the virtual interim we had a couple weeks ago, and Jake Holland and co-authors wanted to have suggested pushing back a milestone deadline for the final version of the OpsCon draft. It caused me to actually look at our milestones. This is like, well, that's interesting. Just not really a good reaction, but there you are. And so I don't think we're going to conclude a discussion here, but it seemed like this was an appropriate time to at least launch a discussion of whether or not we have the right milestones for this working group. And for the items that we haven't particularly embarked on, do we have volunteers or other thoughts? And why, yes, in case you're scrambling to find our charter and what are the darned milestones anyway. Next slide, please. Thank you. So we have some done, which I should really just say thank you, Jake and co-authors. And the proposed new date for the final version of the operational considerations document is for June next year. But there are at least 2 other documents that we had thought when we were chartering might be rational to pursue in this working group, and which we haven't pursued. Now, naturally, some of that is because it's 2020 and what was the question, but some of it is also just because we haven't pursued it. So these are there are 2 key documents. There was a theory that we were going to talk about the relationship of the work that the SIMT folk are doing and what the IETF does, and also the Streaming Video Alliance. We have had some cross chatter between this SVA work and this working group, but nothing so formal as a document. So I guess my questions are, do we want to? And then the final bullet point, I have no idea that's a bogon. That is as it is on our charter, but I don't know whether the ED network considerations document is the same as the operational considerations document. Anyway, it's a bogon. So with that by way of rousing intro, I throw open the floor for comment.
Jake, you're up. Can't hear you if you're talking.
Does that work?
Yes.
Yep.
Excellent. Unmute and yeah. I guess my first question is, do we have any insight into like how our milestones and the achievement of them will feed into the evaluation, which I think is
A year from now.
If I remember right, is a year from now, as to whether the working group will remain active or what exactly? And it looks like Eric is on. Thank you, Eric.
Go ahead, Eric.
This will be okay regarding the audio and the video. So this
sounds good.
Good question, but on the other hand, there will be an evaluation indeed in about a year from now. Having documents was not the main goal of MOPS. It was the documents here are more to document what we are doing and to basically have an archive and not to lose the time you spend specifically as an author, Jake, on this document. So there is no link really between achieving document publication and the survival of this working group. Now, having a document like yours that's lingering for years is not a good sign either. It's not lingering for years, right? But if it ever stands before going to the working group last call for years and years and years, then it's not a good sign.
Yep.
And basically, I'm confident it will be working group last call before the end of the year or early next year, right? So don't take it as a criticism there.
Spencer, did you want to throw something in there?
Mine was actually on a different point. I can get out of the way. You could let anybody who wants to follow up with Eric talk.
So I think part of my takeaway is that, so what I understood Eric to say basically is that no, we're not going to be graded uniquely on the completion of these milestones, but we should be focused on being clear about what work we're doing, and if there are other documents that we should be working on, we should be identifying them. And I apologize if I seem a little distracted. I think my cat might be chasing a mouse in my office, so shrieks may ensue.
So if you don't mind, I confirm what you just said, Leslie. Having the right milestone now, having fuzzy milestone like there is on this charter, if you don't intend to work on SMT and SVA, simply remove them, right? There's nothing as bad as having a wrong milestone. We can delay, we can change them, but having milestone where nothing is moving there, just remove. That's easy, and you have the power to do it as chairs, as you know.
Right. And I guess on the SVA, sorry.
Oh no, I was just going to say. I mean, it just we put these milestones in place for a reason, right? So I'm just sort of wondering if the reasons have changed. I don't think that's the case, and if it's just a matter of getting the energy of activation to get them started, right? Having the right people in the working group to help advance them.
Yeah, so I think that that's part of it, and I think part of it is in the case of SMT, there were folks that were maybe more involved a year ago or going to be involved a year ago, and then 2020 happened. So that's one that we might want to sort of put in the parking lot, and should the right people become involved again, we could pursue it. Streaming Video Alliance, we've had people present work from there, both Sanjay Mishra talking about the work of the open caching stuff that's being done there, and also our last virtual meeting, Virtual 108, we had the presentation about the measurements, the metrics for video quality of experience presented here. So I think it's a question of whether or not there is interest and volunteer to actually do some work on documenting where there is clearly overlapping work. And Glenn, why I see you're in queue.
Technical advisor.
Perhaps you'd like to say something.
Working.
Yeah, there you are.
Are there yet? Awesome.
Yeah.
Yep, I can hear you.
So, I do think a lot of this is because 2020. So I do think that both of them are reasonable things to continue within the milestones. Maybe with some different dates, obviously, since I think we missed July 2020. But both of these topics to me seem still relevant, right? SMT's still got their 2110 specification, which is using IP networks for their work. SVA, as Leslie said, has the CDN work going on over there, as well as some other stuff that is ongoing. So I think we should keep both of these, but maybe be more conscious and putting some energy into working on both of them. And if one of them turns out, that one or the other isn't really getting a lot of energy back from the other side of that relationship, then we can talk again about killing it off. I think it's premature to kill them off right now.
So before we go to Spencer on a slightly different point, do you, because I know you're deeply involved with the SVA, do you have suggestions who might actually be a good person to, for us to hunt down to actually take the pen on the SVA document?
I think Sanjay and I should have a conversation. I'm not volunteering him, I'm not volunteering me, but
Right.
I think the two of us together can have that conversation about who, either both of us or somebody else might be the right person, because both of us are clearly active in the IETF and we're both active here. So, although I don't see Sanjay on the call tonight, he may be asleep.
Imagine that. Okay, so I take that as take those as suggestions. Thanks. And maybe we should let Spencer get his word in edgewise. Spencer?
Okay, so I'm talking, sorry.
Yep.
So I had a couple of things that popped up after I stopped talking a minute ago. But it seemed like to me that what we were talking about was two things in the in MOPS, and one was about operational recommendations, and one was about outreach to other forums. And I think both of those are really valuable, and I think that and maybe we're proving that this is actually true, but that the outreach is probably going to take longer to develop. So that's a good thing for us to start for a while before we decide how successful that's going to be. On the question about the edge networks, which is actually what I was thinking about when I pushed my button. I think that the operational considerations for streaming document hasn't really talked about edge networks very much in the parts that I've worked on, at least. I think that's a place where the edge computing topic that we were discussing a minute ago might reasonably fit. And that was why I was asking about, is this also about configuration for edge computing in support of video? That may be the kind of thing that would end up in that document that would not end up in the streaming considerations document.
So that's a fair point. I'll simply observe that I flagged it as a bogon because it was a document that was being last called in our milestones without ever having had an initial draft or anything else.
Yeah, well, that's not a good sign. No, even the cats won't go for that.
No, they'd rather hunt mice. So, I do think that there is a question then whether we want to have such a document as distinct from the operational considerations. So I think. Sorry, go ahead.
I'm sorry.
Nope.
So I guess one of the questions I was wondering about on that is anybody else thinking about operational considerations for configuring edge computing?
Opening up to the floor. Okay. Go ahead.
Hey, this is Shui. Just kind of reply to Spencer. I think Spencer also knows. I think in FuturePP, there are multiple work on edge computing aspect, right? Mostly SA2 and SA6. But I think in this work, pretty much close to S6 work, application level edge computing considerations. And I totally agree with Spencer. The current documentation missing lots of existing edge networking architectures, right? We're talking about the media streaming and computation and edge server location and resources, and those still need to be considered documented somewhere, either in the same documentation or in separate documentations. Talk about that. I mean, the current draft is too broad to comprehend it. In my perspective, is that okay, Spencer? I think.
Yeah, I may be guessing a little bit at this, and this is actually a good conversation for us to involve 3GPP liaison types, both our person to the 3GPP and 3GPP's person to us, to talk about this a little bit, maybe. But my impression is that 3GPP does a lot more with how to with mechanisms to do things than maybe how, operational considerations for them and things like that. So if they're using IETF protocols, especially for any of this, that it might be a really valuable thing for the operations area to do, whether it's in MOPS or someplace else. Thank you.
Okay, so I think my takeaways at any rate are that we should definitely update the milestones with the updates for the operational considerations document. It sounds like I will propose something along the lines of pushing out the milestones for the SVA document and the SMPTE documents, and we can revisit at 110 whether or not there really is movement on the SMPTE documents, or if it's a dead option, and also to pull up some earlier milestones on the Edge network considerations document to see if we can get some work going there for an actual document separate from the operational considerations document. That's what I'm hearing from this discussion. I would propose that that's material to be proposed to the mailing list for further discussion. Does that sound right to you, Kyle?
Sounds right to me.
And throwing it open to the floor again, does that sound right to people? Any objections? Okay, you're hearing sounding right. Okay. Go ahead, Spencer.
I was just going to say, I think I'd be happy to work on the Edge network considerations document with other people as well, of course.
Awesome. Even better. Great, thanks. Okay.
All right. Have we gotten to the all other business section of the meeting?
Yes. And I agree with Chris Lemon's comment that given the amount of cross-pollination between the SVA and IETF, the SVA doc seems particularly useful. We just need to provoke it at this point, I think.
Yeah.
Yeah, so I think we are exhausted. We have exhausted our list of things. So yes, any other business? We're in danger of calling this meeting done. So if anybody else has anything else to say, now is the time.
Oh, yeah, coffee. Not right now. Maybe if I wanted to stay up until 6.
All right, going once. Beer is a different discussion.
Yeah.
Yes.
Any other beer? Yeah. Yeah, I think that might make a good April 2021 RFC, April 1st RFC.
We can but hope.
Yeah.
Great. Well, thank you very much, everybody, for coming out and playing. I think it was a good discussion. I'm hoping that my cat is asleep under my desk and hasn't actually found a mouse. Well, it's better than the time they found a bat. That was really bad. But anyway, thanks everybody.
All right.
Thank you all.
Thank you.
And thanks to Mike English for taking the notes.